Hi everyone. Today we're going to explore a beautiful idea from celestial mechanics called the Kozai-Lidov effect. I'm joined today by a small astronaut assistant right here with me as well. So this one is going to be interesting. And in fact, it's one of those phenomena that reveals something subtle and quite elegant about the universe. For example, when we first learn about orbits, we often imagine them as simple and stable. For example, a planet circling a star, repeating the same path again and again. But in reality, many systems in space are not made of just two objects. They're made of three or sometimes even more. And when a third object enters the picture, something fascinating can happen. So imagine a star with a planet orbiting relatively close to it. Now imagine that much from further away, another massive object is also orbiting around the same star. This distant companion could be like another star or a large planet or even a compact object. So at first glance, everything might look stable. The inner planet follows its orbit, and the outer planet object rather follows its own much larger path. But gravity is patient. Over very long periods of time, the distant object's gravitational influence begins to gently reshape the orbit of the inner body, and those changes are slow, almost imperceptible from one orbit to the next. So that happens over thousands or millions of years when a remarkable pattern begins to appear. The orbit of the inner body slowly stretches, then its path becomes more elongated, and at the same time, the tilt of the orbit begins to change. Then something equally fascinating happens. As the orbit becomes more stretched, the tilt decreases. Later, the process reverses. The orbit becomes less elongated while the tilt grows again. So, in other words, two properties of the orbit begin to trade energy with each other. And then we have inclination, which describes the tilt of the orbit, and eccentricity, which further describes how stretched that orbit becomes. And this rhythmic exchange is what scientists call the Kozai-Lidov effect. The Kozai-Lidov effect was independently discovered in the 1960s by Yoshihide, Kozai, and Michael Lidov. Both were studying how gravitational interactions between three bodies could produce long-term changes in orbital motion. What they discovered was not chaos, but it was kind of slow gravitational choreography. And when the outer object's orbit is tilted relative to the inner orbit, the gravitational interactions between the bodies can produce these oscillations between inclination and eccentricity. So over time, the orbit evolves, almost like a system reorganizing itself. This mechanism turns out to be incredibly important across astrophysics. It helps explain why some planets have very elongated orbits. It may play a role as well in the formation of certain hot Jupiters, giant planets that orbit extremely close to their stars. And it can influence the dynamics of binary star systems. And in some cases, it even helps drive interactions between black holes that eventually to merge. What makes the Kozai-Lidov effect so fascinating to me is that it shows how systems that appear simple at first can contain hidden layers of structure. And as a planet orbiting a star might look stable when viewed in isolation, when a distant companion enters the picture, we can observe subtle gravitational influences that are accumulating over time, which slowly start reshaping the architecture of the entire system. So in that sense, celestial mechanics often behaves like a kind of long-term systems thinking. Small influences, repeated patiently over immense timescales, can transform the behavior of an entire orbit. The Kozai-Lidov effect is a reminder that gravity is not just a force that pulls objects together. It is also a force that organizes motion, distributes energy, and quietly reshapes cosmic systems across millions or even billions of years. And to me, that's one of the most beautiful things about studying the universe. The cosmos isn't only made of dramatic explosions or bright events. It is also full of slow, elegant processes unfolding across vast stretches of time. The Kozai-Lidov effect is one of those processes, a quiet gravitational dance guiding the motion of worlds. Thank you for joining me today. I hope that was interesting. I hope that you learned something new. And thank you again. Take care.